As you may have seen in my previous video, I started doing a bit of traveling, and I can't really go anywhere without bringing a whole arsenal of tools and gadgets with me. But often it turns out that the items are too heavy for most trips I take. So, in this video I will focus on making a device that I can take with me anywhere I go, without breaking my back. With that said, I will use this video to build and showcase a tiny MIDI keyboard packed with functionality. This is what it looks like, but more on that later. The first thing I do when I start a new project is create a schematic and a custom PCB. I'll show you my full process in a minute, right after I tell you about today's sponsor, JLCPCB. JLCPCB is a high-quality PCB manufacturer that makes the highest quality PCBs for the lowest prices. They are an essential tool for every maker. JLCPCB is a one-stop shop for all your project needs, offering easy, affordable and reliable services. They provide flexible PCBs, PCB assembly, SMT stencils, PCB layout services, 3D printing services, CNC machining, mechatronic parts and more. Ordering PCBs from JLCPCB is simple and intuitive. You simply need to drag your Gerber files onto their website and you can get an instant quote. For the PCBs you can choose various customizations such as color, thickness and so many more settings to choose from. The best part is that you can get 5 boards up to 10 by 10 cm for only $2. Get your PCBs made by JLCPCB today by signing up with the link in the description. Let's start by making the custom PCB. I go into EasyEDA and start a new project. I have my most frequently used components saved into a favorites list. I use the Arduino Pro Micro for building MIDI controllers, so I'll add it to the schematic. Next I need a 16-channel multiplexer. Then I'll add a unique type of encoder that will be used for pitch bend, 2 potentiometers for controlling effects, and I need 13 mechanical keyboard switches to make a whole octave of keys to play notes on. Finally, I'll add 2 push buttons that we can later map to anything. The next thing I do is, I add labels to the Arduino pins that I can directly connect to components, so I don't have to draw wires and connections through the whole schematic. And I'll connect them to the corresponding pins. Next, I can connect pins 4, 5, 6 and 7 of the Arduino to the multiplexer's channel select pins, and pin 8 to the multiplexer's signal pin. Now I can add VCC and ground to the multiplexer, where ground connects both to ground and the enable pin. And I'll add the rest of the labels to the multiplexer. Now I can use those labels to connect all the switches, buttons and encoder button to the multiplexer. I can proceed to add ground labels, though in the video I forgot to add the VCC label and connect it to the Arduino. I fixed it later off camera. For the potentiometers, we need one pin connected to ground and the other to VCC, while the middle pin, called wiper, is connected to an analog pin of the Arduino. I can proceed by connecting all the components to ground. Now I'll use pins 2 and 3 of the Arduino, which have hardware interrupts, to connect the encoder. This will allow us to have clean and fast reads of the encoder. And I'll connect the potentiometers to Arduino pins A0 and A1. Now I have the schematic ready. I can test the connections, rename the sheet, and continue to create the PCB. Creating the PCB is rather simple when making simple projects. It all comes down to coming up with a shape and placing all the components in their respective position. I'd start by placing the mechanical switches first, and each of them is spaced 20 mm from each other. I'll make sure to place them in a piano keyboard layout. Next, I'll find a place for the encoder and potentiometers. I have to figure out where to place the microcontroller and multiplexer, since they take up the most space, and I have to make sure I place them on the bottom side of the board as well, so I can proceed to place the push buttons and the Arduino at the end. When I'm satisfied with the positions of each component, I can set the board outline to cover all the components. I have to note that I forgot to add mounting holes for screws to pass, which I also added later. Finally, I need to personalize the PCB by adding an image or a logo, the project name, and my website. Once everything is done, I use the auto router feature of EasyEDA to route all the connections, and I'm ready to export the Gerber files and order my PCBs. While I'm waiting for the PCBs to arrive, I usually create the 3D model for the enclosure, but I'll leave that guide for another video. I usually make simple boxes with cutouts for the components and standoffs for heatset inserts and screws to mount the PCB. The PCBs arrive usually within a week. They are packed neatly and they look pretty good, especially with our custom labels. Now it's time to solder all the components. I usually start by soldering the pin headers to the Arduino Pro Micro, because it comes with no pre-soldered headers. Once that is finished, I move on to doing the same for the 16-channel multiplexer. Now I can solder both components to the PCB. Would you look at that beauty? The pin headers for the multiplexer are too long, so I have to trim them down. Be careful with this process. Now we can add the encoder. This is a special type of encoder because it is not a rotary encoder, in a sense that it doesn't rotate endlessly. Rather, it has a spring mechanism that pulls it back in the center position, so it can do only one step in each direction. This is pretty good for a pitch bend. It does have a button as well, which we can program to toggle half step and full step bends. Then we can add the two potentiometers. And finally, we can solder the two push buttons, which will be programmed to change octaves. Now it is time to prepare the enclosure. All we have to do is use the soldering iron to gently press the heatset inserts. Once this is done, we can screw the PCB in place. Notice how we didn't solder the mechanical switches. That's because the enclosure also doubles as a plate for the mechanical switches to snap to. This helps with stability, and we can make sure that each switch is centered and positioned correctly. Now it is time to beautify the controller by adding all the keycaps. This is the final controller, and I think it is perfect for what it needs to do. But let's upload the Arduino sketch and see it in action. I'll just improvise a short beat to demonstrate its versatility. And there we have it. Well, you've reached the end of the video. Congratulations and thank you for staying till the end. As always, all the project files are available for free on my website. And if you want to get your own, visit ristoinnovates.com or click the link in the description. I'm gonna ask you to leave a comment, like and subscribe if you want to see more video projects like this one. My name is Risto and I will see you next time.